Hello guys, welcome back to Maison African Motives. Still on our revisions for ZIMSEC. This is O-Level Mathematics 2023 exam November. Guys, to be honest, if we are to check throughout our question papers, we'll see that this was just a repetition. I have not seen any new question. Actually, it was just a repetition, and this was one of the most and easiest papers that we can consider in the history of our ZIMSEC department. That one, I just want to give a thanks. It was actually not the easiest, but it was something that you can answer, and you see that at least you've got something there. Okay, let us see, because it might be like it's something that is difficult. Let us go through our question paper and check. Thank you so much for those who are part of helping us to obtain these question papers. You see, our department, yes, I do not know. You see, these question papers, they are just supposed to be there, available on the website for the department. You see, the department of ZIMSEC, it has a website. These question papers, they are supposed to be there, uploaded, each and every question paper that is written. But I don't know. I do not know. But anyways, guys, those really want Tongo ita zviripo. Anyways, we are given question number 1, express a 4,695 to 2 decimal places. You are given the instruction here to 2 decimal places. All right, so let us consider our decimal places is 4,695. So 2 decimal places, you're going to count 1, 2 after the comma. So 5 can change this 9 into a 10, and it gives 1 here, it becomes a 7. So that was at the end going to be 4,7 0 in this case. You are supposed to write this 0 because you are told to 2 decimal place. So you are supposed to indicate this 0, but the other one this one was supposed to be a 0, you do not indicate that, just this one. Okay, you're supposed to have that on your answer. 1 mark for that. All right, 794,3 to 1 significant figure. So we're just considering the whole number. The first whole number that we have is 7. So it's 794,3. And the first whole number, which is a significant digit, there is 7. So is it going to be changed by this 9? Yes, 9 is greater than 5, so it can change this 7 into 8. The rest of these digits become zeros. So this will be a 0 here, this will be a 0 here, comma, this will also be a 0. But this comma now after the comma is not important. So it is just going to be 800, just like that. All right, 1 mark for that. In standard form, yes, as you can check, this is an ordinary number. So remember, to be in standard form, we have to write in the form of a times 10 to the exponent of n, whereby a is a number between 1 and 10. So you're just going to consider how many commas are you going to move from this number. We're going to move until it gives us a whole number. So that's 1, 2, 3. So we have moved 3 commas so that it can be 2,3,1. So that we can have 2,31. So that's times 10 to the exponent of 3. The number of commas 1, 2, 3. But now you have to consider to say we are starting with a 0 digit. So whenever you start with a 0 digit, this power or exponent will be a negative. All right, that's it. 1 mark for that. And that's it. All right, let's check question number 2. Write down the number. Okay, so you see now this issue of someone will be scanning this paper. It will be something else, but you see our department, guys, is not fair. Let us just hope they're going to improve as time goes on. We need these question papers on the website of the Department of ZIMSEC. We need these question papers to be uploaded. All right, anyways, write down the number. We're given this number, that's 7 times 8 to the exponent of 3. I'm just going to write what I'm seeing here because, as you can see, guys, it's 3. Okay, that's 8 to the power of 3 plus 8 plus 6. Okay, so we're asked to write this number as a number in base of 8. All right, in base of 8. Remember, this is just a conversion that was happening from a number in base of 8 to a number in base of 10. If I'm given maybe a number 1, 1, 2, to a base of 10, I have to write 2 to the power of 0 to the power of 1 to the power of 3. That will be, if I change this to base of 10, it will be 1 times 2 to the power of 3 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. So as you can see, it's a conversion that was happening from the base of 2 to the base of 10. So it's the same thing that we can see here. Writing in terms of powers like this, it means we are converting from the base, which is the base of 8, the one that is carrying the power in this case. So it's either you can convert this to back to the number on base 10. I mean, you convert as it is to base of 10, or you just change it because it was from base 10, from base 8, I mean. So you can just write it back to the base of 8. That's why you see it's 1 mark there. So what is the condition? We just have to, we see that we are supposed to have this in terms of the powers of the base, the power of 0, 1, 2, and so on. All right. Oh, that's a 2 there. Where am I writing a 3? That's a 2 here. That's a 2 there. So you're supposed to have 0, 1, 2, and so on. Okay. So using that concept, you can see here we've got a power of 3. So that means this number was 7 times 8 to the power of 3 plus the following supposed to be 3, 2, 1. So as you can see here, we do not have the exponent of 2. This is 8. This is same as 8 to the power of 1. So we do not have to the power of 2, just like 2, 1, 0 in that order. We're supposed to have 3, 2, 1 up to 0. So it means that number was being multiplied by a 0 because 0 times 8 to the power of 2, it gives us what? A 0. So it means the 8 to the power of 2 that we do not see here, it was multiplied by a 0. That's why it is not indicated on this platform, on this number. So it was 0 times 8 to the power of 2. Already we've got 8 to the power of 1, but what is the number that is affecting that? It's a 1, because for you to get 8, it means you multiplied by a 1. 1 times 8 gives you that 8. So it means here it's 1 times 8 to the power of 1. Then the next one, we see a 6. We are not seeing 8. It's just like this part. If you see a 1 here, it does not mean that the 2 to the power of 0 is not there. It's there because 2 to the power of 0, remember, it's 1. Then 1 times 1 gives us a 1. So what made us to obtain this 6 that we see? It means we were multiplying 6 times 8 to the power of 0. So that's the concept, 3, 2, 1 up to 0. So if the power that we're having here was 4, it was supposed to have the same order, 4, 3, 2, 1 up to 0. So if we are to check the number that we had in base of 2, it was 1, 1, 1. From these numbers here, 1, 1, 1. These are the numbers that we are just taking in base of 2, which is the number that is being raised to the power. So if we check the numbers that we have, that's a 0, a 7 here, a 0 here, a 1, and a 6. So these are the numbers that we had in the base of 8. In the base of 8, the numbers that we had there, it was a 7. Here, there was a 0. Here, there was a 1. Here, there was a 6 in base of what? In base of 8. So this is the number that we had in base of 8 that we're trying to convert to the base of 10. So we've got 0, 1, 2, 3, which is this part. So if you want, yes, convert that to base 10, find your number in base 10 to convert to base 8, to divide by the base throughout, you're supposed to have the same answer. All right. Convert 57 base 10 to a number in base 6. All right, so for you to convert this number to a number in base of 6 from base 10, you simply have to divide by the base. So that's 6 into the number in base of 10. We are going to note our remainders here. So we're going to divide, noting the remainders, all right? So let us divide 57, divide by 6. It is going to be into 54. Into 54, it is going to be 9 times into 54. Remember, 9 times 9 times 6, it's a 54. All right, so 57 minus 54, that's going to give us a remainder of 3. So we are going to have here a remainder of 3. All right, we divide again by 6. 6 into 9 is going to be 1. That is 6 times 1 is 6. So we're going to have a remainder of 6 minus, 9 minus 6, which is a remainder of 3. So here we are going to have a remainder of 3. Then we divide again 6 into 1. That's a 0. Remainder 1. So you're going to have remainder 1 in this case. All right. So this is your answer in base of 6, but you have to take it from the bottom going up. Remember your concept, from the bottom going up. So meaning to say our answer in the base of 6, it is going to be 1. 3, 3. So it's 1, 3, 3 in base of 6. All right, so that was the idea of our question in this case, to convert a number from base 10 to base 6, simply divide by the base. All right, evaluate these two numbers, giving your answer in base 2. So it's an addition that we are seeing here. That is, we are given 1, 1, 1 base 2 plus 1 base 2. Guys, this question paper, I do not know, but it was a nice question paper, this one. All right, let us add 1 plus 1, that's 2. Remember, if you're adding, you cannot write a number equal or greater than the base. So once the number is equal to the base or greater than the base, you have to divide by the base. Like here, 1 plus 1, that's a 2, is equal to the base. So you divide by the base. So 2 into 2, that's a 1, remainder a 0. So the remainder is the one that you're going to write on your answer here. So we've got a remainder of 0. Then this one, we carry it to the next term. So it's now 1 plus 1, which is a 2 again. 2 is equal to the base. We divide 2 by 2. That's 1, remainder 0. So we write the answer, our remainder, which is 0. Then this one, we are going to give it to the next term, just like the previous part. We do the same. 1 plus 1, that's a 2. So we are going to divide again. 2 by 2, 1, remainder 0. We write our answer, which is the remainder. This one, we give it to the next term. Which next term do we have? We do not have, so we're just going to write it as a 1 like that. So that's 1 plus 0. We do not have a number corresponding. This is a 0, a 0, a 0. So that's 1 plus 0, which is what? Which is a 1. So you're going to have this 1. But remembering that we are in base of what? We are in base of 2. All right, so that was our answer there. 1 mark for that, which is fine. That is fine. All right, let us check question number 3. Express this in this time that we see here in 12-hour notation. So this time is in 24-hour notation, and we're asked to express in 12 from 24-hour notation. 02, it means this is in the morning. That's AM in this case. So this is just going to be 2:17 AM. All right, it's in the morning. If it was 14:17, this is the 2 of the afternoon. So it's going to be 2:17 PM. All right, so this one is going to be AM, and time you just indicate with a dot like that. All right, dot. This one is the one that you see on your phone or on the normal clock that you see, not the normal time. The normal time is like this. You just put a 1 dot there. All right, question B, for a general parallelogram, state the number of lines of symmetry. What is a parallelogram? That is the concept. You have to ask yourself, what is a parallelogram? All right. And also, this one, I think it was best if I can have it as a shape. But let us just see. All right, let us see. If we are to take a parallelogram, we are just saving a shape of this nature. Okay, that's our parallelogram. I just hope it's gonna make sense, because it wanted me to actually show you with a picture, like to rotate a picture and see what is happening. This is our parallelogram. It follows that these two sides, they will be parallel and equal. All right, these two sides, they'll be parallel and also equal. So the lines of symmetry are talking about a condition whereby we divide our shape. We can divide our shape like this, then it closes. Like for an example, let me put a rectangle so that you can properly understand. A line of symmetry for a rectangle, if I put it this way, this piece can close to that part. So these two, they are equal. Or I can put it this way. This piece here on top is going to close with this part down. Like I said, it needs me to have a shape, but I hope you understand me. So if you are to check on a parallelogram, there's no way we can divide and it closes. This side and this side, this one, it will overlap this side. This one, it will overlap this side, so it won't close. There is no way we can do it this way. There is no way we can do it this way. This side is gonna overlap here. This side is gonna overlap this side. And also there's no way we can put it this way. It will overlap and overlap. So meaning to say, as for the number of lines of symmetry, here we do not have, it's going to be a 0. So a normal parallelogram or a general parallelogram, it is going to have what? It is going to be a 0 in this case, number of what? Number of lines of symmetry. All right. Then we have got the order in this case of rotational symmetry. The order is that when we change this, like when we rotate it 360 degrees, where are we going to have it in the same manner that we have? So if we see this side here and this side are the same, and if we rotate what we see here, we are going to see it on this side. So we can rotate it 2 times to have it to have the same shape that we see. If you rotate it the other side, if you place this side here down and you place this side up, it is going to be the same shape that we were seeing before. So that's what we are trying to say. So the first one is the one that we are seeing as it is. The second one is when you place it on top. This side here is going to be the same as this side, and the shape is going to be the same as what we see. So for the order of rotational symmetry, about the center, it is going to be taken as 2. For a parallelogram, a general parallelogram, it is going to be what? It is going to be a 2. That is the order there if we take it from the center. Let's just hope we understand. But for shapes, you're supposed to know each and every shape, that is each and every plane shape which are in your syllabus. You're supposed to know their lines of symmetry and their corresponding order of rotational symmetry. All right, question number 4, we are given f of x, which is equal to 3x minus 1. Find f of minus 2, guys. F of minus 2 simply means in place of x, you substitute minus 2. So that's f of minus 2 is equal to, where there's x here, I'm going to substitute negative 2. So that's it. Let's multiply 3 times negative 2. That's negative 6, negative 1, which is going to be a negative 7. Here, that's 6 plus 1, which is a 7. Then we take the common sign. So that will be a negative 7 in this case. All right. Then find x if f of x is equal to 5. Guys, this one, okay, let us see. They are saying f of x is now equal to what? Is now equal to 5. What was our f of x before? We have to take our f of x as it is here. Remember, our f of x is 3x minus 1. So we are going to take our f of x, which is 3x minus 1. That's our f of x. We equate it to 5 like this. The moment we equate it to 5, we can solve this equation, because now we are talking of what? We are now talking of a linear equation. This is a linear equation that we see here. We're talking about a linear. So you can solve for x. So you're going to transpose negative 1 to the other side. It becomes a positive. So that's 3x is equal to 5 plus 1, which is 6. All right. So that will be a 6 here, divided by 3, so that we have the value of x. So 3 into 6, that is going to be what? A 2. So the value of x here was going to be a 2. All right. Then question number 5a, simplify negative 3m to the exponent of 4. So we're given a negative, which is affecting the whole bracket in this case. I mean, an exponent that is affecting the whole bracket. So the negative is going to be affected. Remember, a negative, when raised to an even exponent, if you take a negative and you raise it to an even number, it becomes a positive. If you take a negative, you raise it to an odd term, it remains a negative. All right. So here we've got a negative to the exponent of which is an even number. So it's going to be a positive. All right. So you're going to have a positive. 3 will be raised to the exponent of 4. M will also be raised to the exponent. Every number, every term inside. So 3 to the exponent of 4, that's 3 times 3 times 3, 4 times, which is going to give us 81. So you're multiplying 3 times 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. 27 times 3, which is 81. And take note, it's a positive. So that's 81 to m to the exponent of 4 in this case. All right, so that was it, 1 mark. Let's check the B part of it. It was evaluate. All right, you see that a problem of scanning these papers. This one is not that clear, but that's 49 to the exponent of 3 over 2. So we've got 49 to the power of 3 over 2. Remember, from our law of x to the exponent of a over b, we obtain the bth root of x to the exponent of a, which is the same as the bth root of x to the exponent of a, like this. All right. So it's one and the same thing that we see here. So meaning to say, when we are given this, the number in the denominator here becomes the number in the square root. So that's a 2 there. So we've got the square root of 4 to the exponent of the power which is our a, becomes a power, which is 3. So what is the square root of 4? Remember that the square root of any number, it's a plus or minus. So it's going to be plus or minus 2 to the exponent of 3. Remember what I said, a negative to an exponent of odd number, it remains a negative. So this is what we obtain. Okay, it was on the last page. Let me just show you a little bit here so that you can also be with me. Remember what we said here, a negative when raised to an odd number, it becomes a negative. So meaning to say, if we are to consider this part here, we are going to have our answer as plus or minus, because plus raised to any power, it remains as a plus, minus to an odd power, it remains as a negative. So 2 to the exponent of 3, that's 8. 2 times 2 times 2. So that will be an 8. 2 times 2, that's 4. 4 times 2, which is 8. So we're going to have a plus or minus 8 on our answer. All right, 2 to the exponent of minus 3 on the item 2. 2 to the exponent of minus 3. How do you remove a negative? It's 1 over. So that's 1 over 2 to the exponent of 3, which is 1 over 8. Remember, we talked about 2 to the exponent of 3 here, which gave us 8. So that will be an 8 there. Solve the simultaneous equations. Choose your own method. You're not told which method to use. All right, so let's 3x plus 2y is equal to 8. 5x plus 3y is equal to 4,5. So let's see if we are to clear. Yes, you can clear the decimal. Is it 4,5? That's a 4,5. All right, so let's just hope it's a 4,5, because I'm seeing like it's a 4,5 there. So you can clear the decimal fraction. It's up to you, or you can just choose to eliminate either x or y here. So sometimes be careful when you're doing these things, because this is in your hands. You work it the way that you want. And also by checking here, I can see that, all right, there's a 5 here. If I multiply this 5 by a 2, it becomes definitely a whole number there. So instead of me focusing on clearing the decimal, I can just eliminate y here. By eliminating y, it means I'm going to multiply on top by 3, down, I'm going to multiply by 2. Remember that 2 times this is my major focus. The moment I multiply 2 by this, it gives me a whole number. So there's no need for me to clear the decimal. I'm working with the bigger values. No, just multiply. Even if you want to eliminate x, it's fine. It's up to you. So here we want to eliminate y in this case. That's why I interchange the part of y. I'm just focusing on these two, because I know that I'm going to have a whole number, because 5 times 2 is a 10. So I have a whole number already. All right, so let us multiply 3 times 3. That is going to be 9. So you're going to have 9x, 3 times 2, which is 6y is equal to 3 times 8, which is 24. 2 times 5, which is 10x. 2 times 3, which is 6y, is equal to 2 times 4,5. That's a 9. 4,5 times 2, 2 times 5, that is 10, got 1. 2 times 4, which is 8, plus 1, which is 9. 1 decimal place, so it's going to be 9,0, which is 9. All right, so as you can see, that was my major part, just for me to have a whole number there. But as I'm doing this, I'm seeing that the part of y is the same. So I can eliminate this by subtracting, since these two signs are the same. So I'm going to subtract. All right, so that's 9x minus 10x, which is going to be a minus. So that's minus x. 6 minus 6, that's a 0. All right, we move on to 24 minus 9. So we are subtracting 24, we remove 9, that's going to be a 15. All right, so that's a positive 15. All right, so to find x, since this is a negative, divide by -1 so that it can be a positive. So x was going to be here, it's a positive, negative, positive, that's a negative. So x is equal to -15. All right, so if x is -15, I can substitute in any of these two equations in order for me to obtain the value of y, or you can eliminate x, you find y. It's up to you. So it's up to you. All right, so I'm going to choose the first equation. 3x plus 2y in this case is equal to 8. So from the first equation, it means I'm going to substitute my x, which is -15. So that's 3 times -15 plus 2y, which is equal to 8. All right. So if you multiply 3 and -15, that will be a -45. All right. 3 times -15, it will be a -45. So -45 plus 2y is equal to 8. All right, let us transpose the negative this side. It becomes a positive. So that's 2y is equal to 8 plus 45. If we add, we're going to be 53. All right, 53 divided by 2 by 2. All right, so that'll be here we cancel y is equal to 2 into 5, that's 2, remainder 1. 2 into 13 into 12, that's 6. We've got a remainder 1. So you're going to have 1 over 2, which is 12. 26 and a half, or we can have this as y is equal to 26,5. Remember, a half, that's 0.5. All right, so that was the idea of our question here. Let us just see what if this is going to make sense. I'm just going to put a calculator, but since we use the substitution, it's going to be difficult for us to prove because whatever value that you're going to use here, it will give us the same thing that we want. But anyways, let us just cross-check because yeah, guys, I'm just working this directly. I never prepared. I just got your pressure, guys. It was too much, and I had to work this question paper because your pressure was too much. All right, 3 times x, which is 15. 3 times negative 15. Sorry, 3 times negative 15 for x plus 2y here plus 2 times y. All right, so that's 2 times the value of y, which is 26,5. All right, so that's 26,5. What are we going to have? We are going to obtain 8, which is a positive here. All right, so that's it. If we do it the same way here, 5 times x, which is negative 15, negative 15 plus 3 times y, which is 3 times the value of y, which is 26,5. We're going to obtain 9 over 2, which is 4,5, which is the same as this. All right, so that's it. I think we are clear on that one. Okay, that's it. That's it. Let us check the other question. 3 marks for that. Okay, simultaneous equation would be 3 marks. It's like that. All right, let us check the other question. That will be question number 7. Question number 7, circle geometry. All right, and that's it. It's 74 degrees. In the diagram, we are given A, T, and BT. A to T and B to T are tangents. All right, remember from our theorems, I said 2 tangents taken from the same point to the circumference, they will be equal in length. So it means from A to T is equal to B to T. And also, if we draw a line from the center to the tangent, this line, it bisects these angles. This one is bisected also into 2 equal parts. So it means the shape that we're going to have here is it will be a kite. From B to O, it will be equal. From A to O, these 2 sides, they will be equal. So the shape ATBO, it becomes a kite, all right, whereby these 2 angles are equal. And as we know that from the center to the from the radius to the tangent, a radius and a tangent, they meet at 90 degrees. A radius and a tangent, they meet at 90 degrees. So it means this whole angle at O plus this angle, they must give us 180 degrees. All right, I talked about this, guys. If you check circle geometry properties. Anyways, let us see. In the diagram, we are given this, and C, the center O, C is a point on the circumference of the circle, whereby ATB is 74. ATB is 74. Calculate AOT. AOT. All right, remember what I said, this angle here and this angle here give us 180 degrees. So we are going to find angle AOB first. Angle AOB is going to be equal to 180 degrees minus 74. These 2 angles, they are going to give us, when I check the properties of circle geometry, I talked about this, guys. All right, so that'll be 106 if we subtract this properly. So it means the whole of this angle here is 106 degrees, but that's not the angle that we asked. No, the angle here is AOT, which is the remaining part here, this other part. And I said from this line TO, it bisects this angle into 2 equal parts. So we are just going to divide. In order for us to find angle AOT, we are going to divide 106 degrees, divide by 2. So 2 into 10, that's 5. 2 into 6, that will be 3. So it's going to be 53 degrees. So it means this part that we see is 53 degrees. The other part is 53. So that's 53 degrees here. And the other part here will be 53. So that if we add this, we get the whole of this angle, which will be 106 degrees. And the other thing, guys, if you're watching these videos, don't use the phone that is using 3G or so forth. Use 4G because this is a quality video. I don't want to lie. If you're using quality Wi-Fi, this video is crystal clear, very, very clear. This is not from, I'm not taking a phone to record this video. No, this is direct from the machine. So if you're complaining about the issue of the quality of the video, check your internet connection and also the device that you're using to watch. If you're using a 3G phone, it reduces the quality definitely. So, all right, anyways, let us answer our question because I'm just remembering this because some of the questions that we receive here, your video is not clear, this and that. Please use a correct device or a correct Wi-Fi or the mobile. I mean the source that you are having there must be fine. All right, anyways, let us check the B part. BAT, angle BAT, BA to T. All right, let me just increase so that we see. BAT is here. That is the angle from B here to A to T. All right, so they are talking about this angle. Let me just put it this way so that we see what we calculated before. They are referring to this angle here, BAT. That's from B to A to T. This is the angle they are referring to. BAT. Remember what I said? I said this angle is 90 degrees. All right, that's the first thing that I talked about. And also I said these two lines, they are equal from A to O, from O to B. We're talking about the radius concept. So it means this angle here at B, this one that I'm indicating, ABO, and this angle at A, which is ABAO, this angle here, and this angle, they'll be equal from what? From the concept of an isosceles triangle. We are talking about base angles of an isosceles triangle in this case like this. Since these two sides are equal, this is our A, this is our B, this is our O. So we are saying these two sides, they'll be equal. The sides opposite to the angles that are opposite to the sides that are equal. So the angle at B, and the angle at A, they're equal. So if we calculate this angle at A, we can be able to calculate the remaining angle because the whole of this angle is 90 degrees. All right, so how are we going to have the angle at B and the angle at A? Remember, we calculated the whole of this angle at O, this one, the whole of this angle at O, which is 106. We obtained 106 degrees. That's the whole angle at all, which is 106 degrees. So in order to have the angle at B and the angle at A, we are simply going to subtract this 106 from 180. We divide by 2. Why? Because these two angles, they're equal. So they'll be the same. So we're going to subtract 180 degrees minus 106 degrees. The answer there, we divide by 2. All right, of which we talked about this. If we subtract this, we're going to go back to the 74. So that's 74 divided by 2, but just subtract properly and see what you're going to have. So 74 divided by 2, that will be 37. 2 into 7, that is 3. Remainder 1 into 14, that's 7. So it means here at B, we have got 37 degrees. Here at A, we have got 37 degrees at A. But the whole of this angle here, the whole of this angle A is 90 degrees. So to find the remaining angle, which is BAT, which is the one that we are supposed to calculate in this case, which is angle BAT, it is going to be 90 degrees minus the 37 degrees. So you're going to have 90 minus 37 degrees, all right? So 90 minus 37, that will be something like 53 degrees, all right? So you're going to have 53 degrees. So this angle remaining will be 53 degrees. Also, this angle ABT remaining here, it will be 53 degrees, all right? So that's it. Or we could have used it this way. Another way to confirm this is this one. Remember, I also explained from this side that ATB, this one, from A to T and T to B, they are equal. So it means triangle ATB is an isosceles triangle. So you could have used that one direct so that we do not subtract anything from 90 degrees. This is our T, this is our A, this is our B. Remember, we want to calculate BAT. This angle is the one that we want to calculate here. All right, so which concept are you going to use? This angle here is 74 degrees, and these two sides, they are equal. So if they are equal, it means the angle at A and the angle at B, they are also equal. So to find the angle A or the angle B in this case, angle A and angle B, they'll be equal, which is simply 180 degrees minus 74 degrees of this one that we are given, the other one that is at what? That is at T, because we're talking about angles that are inside what? A triangle. That's why we are using 180 angles in a triangle. But these two, they are equal. So that's where we divide, all right? So we're gonna divide by 2, all right? So you're gonna have the same thing. The moment we subtract 180 minus this 74 degrees, we are going back to the 106 that we had before. So it's gonna be 106 divided by 2. And if we divide here, we're gonna obtain 53 degrees. So that's this angle is gonna be 53. And this one also is going to be 53, just like what we obtained from this one, 53, 53. So many guys, if you're dealing with circle geometry, it's in your hands. You play it the way that you want. The ball is in your hands, so you play it the way that you want. That's the idea of circle geometry. So that was going to be 53 degrees, which is the same as the first angle that we obtained. It was 53, and this one also is going to be 53 degrees. Okay, let us check another question. That was from the same circle geometry, I think, because here we still, okay, it was done. Is it the same, or maybe I skipped? Answer C. Answer C. This is B. There's another question. Why they say answer C? Because this is B here. C is supposed to be where? On top. On top. Oh, there is it on top here. All right, ACB. There's another angle, ACB. All right, so let us check angle ACB. In this case, where are we having ACB? This is where we have, why is this one giving the same answers throughout? Because this one is giving another same answer. All right, let's see. ACB, that is the one here. So you're going to consider the angle at the center is twice angle at the circumference. So angle ACB, sorry for that. Let me just save this, all right? So angle ACB is going to be simply 106 divided by 2. That's the angle at the circumference. So you just divide by 2, which will be 53 degrees. So this angle was going to be 53 degrees. All right, guys, this was something else. 53, 53. Every answer is 53. All right, anyways, that's it. What are we gonna do? Because that's what we had. So this was gonna be 53 degrees ACB. All right, question number 8. I did the same question similar to this, if you still remember, but on that question, it was actually to calculate the perimeter. It was not to find this in terms of pi. And even for those who are checking on Facebook, I even posted there on Facebook as a picture. It was just a picture where I worked this one, but it was not in terms of pi. Here they wanted the perimeter in terms of pi. Let us analyze our question. In the diagram, each of the small semicircles have got a diameter 5 centimeters. So from this point, let's say it's A, B, C, all right, and so on and so on and so on. All right. So if you consider here, we are given this arcs. This is arc AB. Here we're gonna consider arc AB. Let us just put a point. Maybe it's P, and this is Q. So I'm just gonna consider arc APB. All right, and this arc BP BQC. All right. So there we are given the radius, and we are given the larger semicircle is a diameter of 10 centimeters, which is this bigger one that we see here. If we add the 5 and the 5 gives us 10 centimeters. So the question was calculate the perimeter of the shaded part in terms of pi. In terms of pi is supposed to be on your answer. All right, remember what I said about perimeter. Perimeter is the distance right round. And for the shaded part, we are going to move from A, P, B like this. This is the first part that we are going to calculate the section that was moved. That's perimeter, all right? We move there from B to Q to C. But as we can see, these ones, they are equal. The length or the arc length of AP, B in this case, from A to P to B, this arc, this one, is the same as the length of this BQC, all right? It's the same BQC from the semicircle. This is a semicircle, so you're gonna have the same length, right? But as we're gonna add that part to the length of the bigger semicircle, this one from A to this point, maybe there is another point there, back to C like this. That is your perimeter, guys. That is the perimeter. So perimeter is distance around the shape that is shaded. You are rounding the shape that is shaded. So meaning to say, we are going to consider the length from where? From A, P, B. That is the first one that we're going to obtain, which is, remember, arc length, guys, arc length. Arc length, or the length of arc is given by theta over 360 times 2 pi r from the concept of a full circle. And theta being the angle that is taken from the center like this will be your arc. Theta is this angle. So if you consider for a semicircle, the theta, the angle is 180 degrees. So instead of us having 180 over 360, it is just going to be half times 2 pi r. This was supposed to be the formula to find the length of the arc, which is the length of the semicircle, the length, this one, not the perimeter of the semicircle, no. Guys, the perimeter of the semicircle, you are considering this one. If they want the perimeter of the semicircle, you consider the length of arc plus the diameter. You now have the perimeter. So we are not considering the diameter here. No. We are not considering the diameter. We are only considering the length of the arc. This piece here is the one that we are considering. Only that piece. So that piece that we see is the one that we're supposed to calculate from theta over 360 times 2 pi r. But because it's a half circle, it's going to be half of the circle, or 180 over 360. That's the angle. It's going to give us what? A half. So as you can see, instead of you writing half pi r, guys, we can see that the half and the half will cancel. So it means at the end, we are going to be left with pi r. That will be the length of arc of a semicircle. If you talk of a semicircle, the length of arc, only this length of arc, this one, is referred as pi r. That's pi r. Only the length of arc, it will be like pi r. So meaning to say here, we are going to have pi r of the smaller circle, the first one. So we're going to have pi r of the smaller circle plus pi r of the smaller circle, the second one, this one, because these two, they are the same. So you're going to have pi r. We're not going to repeat again. Theta over 360 times, guys. No. Plus, for the bigger circle, you're going to have the same thing because it will be taken at 180. So it will be 180 over 360 times 2 pi. So you're going to have another pi r, but this one, we're going to use the radius of the bigger semicircle. All right, this r is for the smaller one. All right, so that will be our formula there, guys, that we're going to use. All right, so meaning to say the radius of the smaller circle is referred as the half of the what? The diameter. Remember, our diameter in this case is 5. So half of 5, it means we've got 2,5. And also here, we are going to remain with 2,5. So that's for the smaller circle. The radius is 2,5. So we are going to have the smaller circle, the radius is 2,5 times pi plus the other smaller circle here, the radius is going to be 2,5 again. So it's pi r, so it's going to be 2,5 times pi plus the bigger circle, the radius there is the one that I'm indicating as the capital letter R for the bigger semicircle. Remember, for the bigger semicircle, it means the radius is 5. It's from A to B. That's our radius, or from B to C. So the radius there is 5, not 2,5, but the radius is going to be 5. So it's going to be 5 pi. So that is the expression for our perimeter, guys. We add, these are like terms because they are in terms of pi. So you're simply adding 2,5 plus 2,5, which is 5, plus 5, which is going to be 10. So our answer is going to be 10 pi centimeters. Remember, this is perimeter, so it is going to be in centimeters. So that was going to be the expression, guys, for the perimeter in terms of pi. For the shaded part, we are talking about the distance that is being moved. So here we're just going to manipulate our formula to what we understand. Learn to manipulate formulas in your favor, guys. All right, we shall talk about that. That will be for those who are writing next year. I think it's only that this year, guys, well, it's hectic. I have to work with a lot of things. I have to consider a lot of work, but I just hope for those who are writing next year, we've got a lot of time to talk about. There is a lot that we need to learn in mathematics. I've been discovering as the year was going through that there's a lot of things that I need to explain. If you are still by this time, if you still have a condition, in fact, I don't need to talk about this. Like, but if you still have a condition that you still seek lessons to say, I want to do maths, I want to find someone to assist me. Yet you have this online platform. It means there is a lot that I haven't explained. I want to explain this maths to an extent that we do not have things like online classes or things like extra classes. You know that if I go to the channel, everything is there. That's the level that we want to go. So I've seen that, I've discovered that we still have a lot, because if you guys are still coming back to me and book for online classes, it means there's a gap that is still there, a big gap. And I don't know, let's hope God will give us time to cover that gap. For those who are writing next year, we just pray for the light to shine as much as it can. All right, question number 9. A student scored the following marks in 6 tests. There are 6 tests which are being written. The first one, the second one, third, fourth, and 6th. All right, these are the tests which are being obtained, or the marks which are being obtained in the test. In the test which were marked, and these were 6. Find the value of x if the mean of the marks is 13. All right, it's just a simple question that you are given here. Remember, you just ask yourself, guys, how do I calculate the mean? Remember, the mean is supposed to be the sum of terms over the number of terms. That's the mean, sum of terms over the number of terms. So you're gonna consider the number of terms, all the terms that are being given. So in this case, just because it's an equation, you have the mean, just substitute your values. You've got everything here, the mean you are given. So 13, our mean is equal to the sum. I'm supposed to add these terms together, including the x. So I'm supposed to add these values. So it's gonna be 14 plus x plus 15 plus 19. So guys, that is what we're supposed to do. You add all your terms, but because of our time, okay, let me just write, okay? Because if I now talk about time, they'll be saying, this guy is not having time for us. Okay, let me write 15 plus 13, everything over the number of terms. All right, the number of terms, how many are they? 6 tests. 1, 2, 3, 4, 5, 6. So that's your number of terms in this case. So you're going to divide by what? By 6, which is the number of terms. So as you can see, we have formed an equation that you can use to solve for x. How are you going to solve for x? You're simply going to add all the terms here. 13 is equal to, so you're going to add, guys, I know this is paper 1. I know this is paper 1, but because of time, let me just put a calculator here. Let's add together because I'm not going to be able to finish, but you're supposed to add this properly. 1, 1, 1, 1, 1, 1. All right. But anyways, me, I'm a teacher, guys. I'm not a student. All right, let me add 15. Here, we're going to add 15 plus 19 plus 15 again. All right, plus 13. Okay, let me just hope 1, 2, 3, 4, 5. Okay, so that will be 76. So if we add this, it will be 76 plus, remember there is x here, so that will be 6. All right, everything over 6. So as you can see, we formed an equation where we can solve for x. This is same as over 1. So we can cross multiply here to find x. So let us cross multiply. That will be 6 is going to multiply 13. You are supposed to multiply properly, but here, guys, me, I'm just going to multiply here using my calculator. All right, you are not supposed to have a calculator here. So it's 78. All right, so I'm going to obtain 78 in this case, which is equal to 1 times 76, which is 76 plus 1 times x, which is x. All right, so I have cross multiplied. And after cross multiplying, I can find x by transposing this to the other side. So it's going to be 78 minus 76, which is going to give us the value of x. So x there was going to be 78 minus 76, which is 2. All right, so that's it. So if we are to take these 2 back and prove, we must have the same mean they are giving us of 13. So let us just quickly prove this with our calculator. Just going to quickly do this. I want you to see the calculator. All right, that's it here. All right, let us just quickly add these numbers. Remember, the mean is sum of terms over the number of terms. So it's going to be 14 plus x. Remember, we got our x here as 2. Our x is 2. So we are going to use 2 in this case. That's plus 2 plus 15 plus 19. All right, plus another 15 plus 13 like this. All right, we divide by the number of terms, which are 6 terms like this. We must get the mean of what? of 13 if we do this, and that's a 13. So it means our 2 is very, very correct. Okay, that was it. The number that was supposed to be added. All right, the B part, the mod, in this case, we are asked to find or to determine the mod. Remember, the mod is the number with the highest frequency, the most occurring number. Remember, we now have X here, which is 2. All right, so which one is the mod? Okay, here 14 is appearing once, 2 once, 15 is appearing 2 times, 13 is once, 19 is once. So our mod was going to be a 15. The number that is appearing the most there, that's 15. So our mod was going to be 15 at the end. All right, that was it. This question paper, guys, was a nice one. All right, I don't want to lie. All right, see the median. Remember, the median is the middle term when the numbers are arranged in order of, not just the middle term, they must be arranged in order of size. So we are going to arrange our numbers in order of size in order for us to have what we refer to as the median. So in ascending order, that is in increasing order. In this case, I'm going to have this in ascending order, starting with the smaller value. Remember, we have X as 2, so that's the smallest value, 2, followed by 13, all right, followed by 14, followed by 15 and 15. So you've got 15 here and 15. And the last one, which is 19. Are they all 6? 1, 2, 3, 4, 5, 6. All right, so we've got our 6 numbers there. So if we've got our numbers in order of size like this, the median is the middle term. The median becomes the middle term on these numbers. So as you can see, our middle term, all right, let me just remove this part. Our middle term here is going to be between here. All right, let us cancel our numbers. We've got 2 and 19, 13 and 15. The middle term is going to remain between these 2 numbers. There are 2 numbers that are remaining, which is 14 and what? And 15. So the median or the middle term, we are going to add these 2 terms together and divide by 2. So that's 14 plus 15 over 2. So if we add, that will be 5 and 4, which is 9, 1 and 1, which is 2 over 2. So let's divide 2 into, that's 1, 2 into 9, that is 4, remainder 1. So that will be a comma here. Then we put a 0 here. 2 into 10, which is 5. So the median value was going to be 14,5. In between 14 and 15, there's a number there in between. That is your median, and that number is 14,5. So here we're going to obtain 14,5. All right, that's 1 mark for that. Question 10, a map is drawn to this scale. This one is one of the best. They've given us direct that 1 centimeter is representing 10 kilometers. That's 1s2. All right, express this centimeter in the form of 1s(n). All right, when they are saying in the form of 1s(n), it means we must have 1 centimeter as to n centimeters. We must have the same unit, centimeter as to centimeter. So they are simply asking you convert this to what? To kilometers, because this is 1s(10) kilometers. So if we just write 1s(2), if we write like this, guys, 1s(10) like this is wrong. Because the scale is supposed to be the same unit. If we say 1 centimeter here, you are saying 10 centimeters. So it's now wrong. But here it's 1 centimeter as to 10 kilometers, which is correct this way. But the moment we are to express in this form where we do not have the unit, unless if they write here 1 centimeter as to any kilometers. But here we can't assume. So we are supposed to change the kilometers to centimeters. Remember, in a meter, we have got 100 centimeters. In a kilometer, we have got 1,000 meters. So that means in a kilometer, how many centimeters do we have? It's going to be 100 times 1,000, which is 100,000 centimeters. So meaning to say 10 kilometers, if we convert to centimeters, we're going to multiply 10 times 100,000. That means we're just going to add another 0 here. So it will be 1 million. So it means our scale is supposed to be 1 centimeter as to 1 million centimeters. As to 1 million centimeters. So that's 1 as to 1 million. We can write it that way. meaning to say 1 centimeter, 1 million centimeters, of which 1 million centimeters is what? 10 kilometers. So be careful. You see how easy the question is given, but in that easiness part, in that easy part, it can be something else. All right. The B part here, it was the actual distance represented by 2,7 centimeters on the map. So the actual distance, we're just going to go back here to the scale. Already you're given a ratio that 1 centimeter represents 10 kilometers. This one, guys, was just for you to give us what the map is showing. What do we see on the map? 1 centimeter on the map being 1 million centimeters on the ground, but we have it in a simplified part. So we're not going to go back to this one and start to convert to say, what does it indicate in meters? No, we are just going to use this at the one that we are given already, the simplified one. So we are given before that 1 centimeter indicates 10 kilometers on the ground. So if 1 centimeter represents 10 kilometers on the ground, it means 1 centimeter is equal to 10 kilometers on the ground. This is 1 centimeter on the map. This is 10 kilometers on the actual ground. So when they are talking about the actual distance, they are talking about what we see on the actual ground. So they are asking that given 2,7 on the map, 1 centimeter is what we see on the map. So on the map, we've got 1 centimeter. But on the ground, that same 1 centimeter is 10 kilometers. So what about 2,7 centimeters on the map? It's how many centimeters on the ground? That's the question. Simple proportion. So as you can see, this is going to be more. So it's going to be 2,7 over 1 times 10 kilometers in this case. All right. So we are just multiplying 2,7 times 10. 2,7 times 10. That's we move 1 comma to the right. So this will be 27 in kilometers. This answer is now in kilometers. All right. So this will be kilometers at the end. That's it. That's like that. Not gonna go back to that conversion. No, 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 no. The conversion is already there. 1 centimeter represents 10 kilometers. So here we are now given area now to calculate the area on the map. Take note, where are we calculating the area? On the map. But on the actual area, which is on the ground, the area is 120 square. Take note, this is area. So this one, it was an indication, which is a scale factor. If you check on the similarity, I talked about a scale factor and area factor. So this scale factor, this one, the one that you are given about the map 1 centimeter to 10 kilometers, it's referred to as your scale factor. You use that to calculate the sides. That's why when we were asked to calculate the actual length, I never talked about converting anything. We just used 1 centimeter to 10 kilometers because we are asked about length. But the moment we talk of area, you have to find what we call the area factor. The moment we talk about area, we have to find what? The area factor. So here we are talking about area. So we are supposed to find the area factor, whereby the area factor is simply the square factor, the scale factor to the power of 2, whereby our scale factor is 1 centimeter as to 10 kilometers. So we're just going to square this. So that's 1 centimeter as to 10 kilometers. We square this to find our area factor. So 1 centimeter squared, 1 squared is going to be 1 square centimeter as to 10 squared. So 10 squared, that's 10 times 10, which is going to be 100. So we are going to have 100 square kilometers in this case. So it means, guys, on a map, in terms of area, it is represented by this scale about area. On a map, we see 1 square centimeter. On the ground, we see 100 square kilometers. So this is the proportion that we are going to use in terms of area to say now, if 1 square centimeter is indicating 100 square kilometers on the ground, what about 120 kilometers? That one I am given on the ground. This is what we have on the square kilometers under square kilometers. So this is on the ground. What is going to be the area in square centimeters on the map? That is the question. So it's a simple proportion, is more. So it's going to be this over this times 1 square centimeter. So it's going to be 120 over 100 times 1 square centimeter. So that will be this one, cancels 10 into 12, that's 1,2. So it's going to be 1,2 square centimeters. So it means on the map, guys, we see 1 square centimeter. But on the ground, what are we seeing on the ground? 120 square kilometers. It's a proportion. This is geography. I just hope with time I'm going to offer you classes for geography. I just hope, I'm not saying I'm going to have it. Most of us, if I talk about this, they'll be now on my WhatsApp. You said you're going to have this. No. I said, let's hope. All right. Question number 11, we are given A, B, C are points on level ground. All right, that's a bearing there. All right, this one is the funny part. We have to sketch it. All right, let us just try to sketch this one. So we've given A, B, C are points on level ground such that the bearing of A from C is 205. All right, A from C. Let's just, it's going to be enough here. I have a sketch. Remember, this is a 3-figure bearing, so we take it from the North Pole in a clockwise direction. So that's 0, 90, 180, 270, back to 360. So 205 is between 180 and 270, not more than 270. So you're going to have maybe our 205 somewhere here. All right, this is just a sketch, guys. All right, I'm going to utilize this space. All right, so that's the angle of 205, greater than 180, but less than 270 degrees. So that's an angle of 205 degrees. All right, which is the bearing of what? A from where? From C. So this is our point C going to the point A. So point A is somewhere there. We do not know what's going to happen, but we just know that there's a point A there. That's A from C. All right. And the bearing of B from C, the same point, you see, from the same point, is taken from the same point, is 347 degrees. So this is 347 degrees. So 347 is greater than 270, but less than 360, meaning to say it's somewhere around here. That's where we are going to have our angle of 347 taken from the north in a clockwise direction up to this point here. This whole angle is going to be 347 degrees. All right, where are we going? B from C. So it's to B from the C, we are going to the point B. So B is somewhere there. We do not know exactly where are we having our B, but we just know that our B is going to be at a North Pole somewhere there. So that was the sketch. So here we're going to just join A to B. We do not know what's going to happen. Is it going to be this side, or that we shall see that one when we are finding our solution. So they just join. It's not a problem. Whatever way that you're going to join, the angle, you will see it when you are calculating it. Then you will say, okay, my diagram was supposed to be like that, or it was supposed to be like this. Okay, so that was the question. That was the sketch from the information. There are two bearings taken from the same point, A from C, which is this one, and also B from C. If you check the question paper of November 2011 or November 2010, yes, that was paper 2. On that part, we had the same question like this, but they drew the diagram for us. Now it was you who are supposed to draw it. All right, anyways, let us see the question. Calculate ACB, the angle ACB, C to B. As we can see, there's an angle inside this triangle, and we do not know this angle ACB. All right, what are we going to do? We know that from this point up to this point is 357. From the same point, but up to this line is 205. So we're just going to subtract the 205, this one, from the 347, the whole of this angle here. So just going to subtract to find ACB. So our angle ACB was going to be 347 degrees minus 205 degrees. All right, that's a 0.5. I'm just going to 7 minus 5, that is 2. 4 minus 0 here, that's 4. 3 minus 1 minus 2, that's a 1. So it's going to be 142 degrees. So this was going to be 142 degrees. All right, let us just confirm, guys, because here it's paper 1. I do not have a calculator, so let me just use this one here. All right, so that's 347. 347 minus 205. Let's just confirm. That's 142. All right. So the angle there was going to be 142 degrees. So meaning to say the angle ACB was going to be 142 degrees. Okay. Then the other part was find the bearing of C from B. C from B, all right? How many marks? 2 marks. All right, C from B. That is here, C from B. All right, meaning to say this one is no longer important. This side here, we're no longer important. We got our answer. So I'm just going to remove this part so that you properly see. All right, so this is what we have, guys. And that 205, this one is not even important. All right, so we are asked to calculate the bearing that we're going to have C from B, meaning to say consider C from the point B here. So we're just going to take from the North Pole back to the line that is going to see this angle here. So how are we going to have this angle? It's either we are going to calculate this angle here that is inside this one, since it is the same as this one from our Z angles. Remember, these two lines, they are parallel. So it follows that here we are going to have Z angles. Here we're going to have a Z here, a stretched Z. So the angle that we see here and this angle, they are equal. So you're going to subtract 180 of a straight line from 347. So 347 minus 180 degrees, that will be 7 here. All right, let's just see. 347 minus 180. So that will be 7. If we subtract 7, here that's a 1 and a 2. 14 minus 8, that's a 6. And here that's a 1. So it's going to be 167. Guys, I just want to confirm. You see, here I'm used to a calculator. Here, paper 1, we use calculators. We do not, you know this. Now I'm like, let me not say I do not know, I know this, but now I'm forgetting because I'm now used to a calculator each and every day. All right, so this is 167 degrees. All right, so that was it, which is fine. So that's the bearing of C from B, which was going to be 167 degrees. Or like I said, you can calculate it from here. Remember that these two, they give us 180 co-interior angles. This angle at this point and this angle, they give us 180. So you can calculate this remaining angle from the concept that a complete revolution, we are supposed to have 360 degrees. So if we subtract 360 minus 347, let us just use our calculator. 360 minus 347 like this, you're going to obtain 13 degrees. So it means this angle here is 13 degrees. So to find the remaining one, since I said they add up to 180, it's going to be 180 minus 13. You subtract the other one from 180. So 180 degrees minus 13 is going to be 167. So this angle would be 167 degrees, which is the same answer as that one that we got here. Okay, this question paper, guys, it was so nice. This question paper was nice. It was just direct somehow. There's another directness which is there that I'm seeing. Maybe it's me. I don't know. Maybe I'm seeing the other way. I do not know. All right, here, guys, I can't see anything. Question number 12. These are sets. It's 11 to what? 11 to 20, but the sign here I can't see. Is it less than or equal to what? If you've got a clear question, guys, just send me on my WhatsApp number so that I'll be able to play around this. That's +27618644043. All right, let me have the question so that we can do this question together. And also, if you have the paper too, scan it. You just find the hard copy. Bring out your phone. You scan it properly, place light. You can even find where there's light, put that light, then scan that paper properly. We want to revise that paper two together. All right, no problem. So here, like I said, please, guys, look for this question on a proper part. If you have the question part, just take a picture properly, scan it, then send it to my WhatsApp number. I'm gonna attempt this. All right, question number 13. All right, this one, guys, we wasted our marks, but no problem. Let's see. Question number 13, it was application of trigonometry. If you check the trigonometry video that I worked on the obtuse angle concept, this was the application that we are given in the diagram A, B, C, and A, C, D, A, B, D are triangles such that we've got BC. All right, you see this question, but they took it from November 2004. That was November 2004, paper 1. Yes, November 2004. That's where they took this question paper, or November 2003. Check those two question papers, you see what I'm saying. All right, so they were given these triangles. So we've got this triangle, and we also have the bigger triangle, which is this one, the bigger triangle, okay? Let's see the concept here. We are not worried about being small or big. The concept here is We are given the sides and so forth. So the question was calculate A cos ACD, giving your answer as a decimal. Here they're gonna take a lot of marks there because most of us we're gonna just write as a fraction. They are saying as a decimal. All right, cos ACD. Let us check where do we have angle ACD. ACD. Let me just write it aside here. Cos ACD. So that's it. From A to C to D. Okay. Guys, do not be confused when answering these questions. All right, we want to find the cosine of this angle. And this triangle that we see, this other one, it's a non-right angle triangle. So it's going to be difficult for you to find the cosine of that. So what I'm going to do, remove this line AD. I want you to see what's happening here. If we remove this line, we're going to see properly what I talked about in that video that I was talking about, the trigonometry. If we just remove this line, we've got something of this nature here. We're going to remain with something like this. This is what we are remaining with. All right. Here I'm going to join from this point like this. All right. Well, I removed this part here. All right. So that is our A. This is our B here. This is our C. This is our D. So the question is asking you to find the cos of this angle ACD. What does ACD represent? That's an obtuse angle. It's outside of the right angle, the triangle. Remember, I said inside the right angle triangle, we've got acute angle. This is going to be our acute angle. This is going to be the obtuse angle. And I talked about the relationship between the cosine of the obtuse angle to the cosine of the acute angle. So instead of you finding this cosine of the obtuse angle, you are simply going to find the cosine of the acute angle. Then you multiply it by a negative. So it simply means cos ACD of the obtuse angle is equal to negative cos of the acute angle in this case. So we are talking about the cos of the acute angle, and the acute angle is ACB, which is this angle inside. So you are simply finding, just like this is cos theta, this is 180 degrees minus theta. That's the same question. But here they want to confuse, you know, they don't want to put that theta and 180 minus. They know that you're going to totalize. They ask you in a way that you just get confused. They put this triangle. What for? Maybe for another question, not for this cos, it was just to be like this. All right. So meaning to say, to find the cosine of this acute angle, remember that the ratio, of course, is the adjacent over the hypotenuse from our SOHCAHTOA concept. That's adjacent over the hypotenuse. So you're going to have adjacent over the hypotenuse. According to theta, our adjacent is this side, which is 8. Remember, this is 8. The hypotenuse is 10. So it's going to be 8 over 10 in this case. So that is our cos theta, which is cos of the angle inside. So it's going to be 8 over 10 adjacent over the hypotenuse. So in this case, for cos ACD, which is the obtuse angle, is going to be negative 8 over 10 now. It's going to be negative because it's an obtuse angle, all right? But they say it as a decimal. So 10 into 8, that will be negative 0.8 as a decimal. So that was supposed to be our answer there. It was going to be a negative in this case. So cos AC D was going to be negative 0.8, all right? So that was going to be negative 0.8 as a decimal. Take note, guys, be careful how you answer your questions, all right? Then, is it the only part? All right, there's another one here. The area of triangle ACD, all right? I mean, 3 marks for that. All right, so you need the area of triangle ACD. Let us check our triangle ACD. All right, this is what we have. Okay, this one was direct, only that they just want to confuse us again a little bit, but it's not that much here. If we are to check for this area, we are going to just apply this concept. Remember, is the area of triangle ACD. This is our triangle ACD, this one. There are how many ways here? Let me see how many ways. There are 2 ways. I'm going to explain both. The first way was to calculate the area of the bigger triangle. Since we want to calculate the area of triangle ACD, I'm going to calculate the area of the bigger triangle, which is a right angle triangle. I subtract the area of the smaller triangle. So this was going to be area of triangle ACD is going to be equal to the area of a triangle, the bigger triangle ABD or ADB. All right, so it's gonna be ABD minus the area of the smaller triangle inside here, which is area of triangle ABC. All right, that's it. That was the first one. I'm going to explain about the second option, whereby the area of the bigger triangle, we need half base times the perpendicular height. So we are limited for both triangles. The smaller one, we do not have the base and the height. So which triangle we're going to use? We're going to use triangle ABC to find the third side, because that's a right angle triangle here. So in triangle ABC, let us just do this aside. In this triangle ABC, this one, we're going to use it to calculate for the third side. But if you know your Pythagorean triples, you're going to see, okay, this is 8, this is 10, this is going to be 6, just like 3, 4, 5. Those are your Pythagorean triples. 5, 12, 13. Those are Pythagorean triples. If you do not know, then you're going to use your Pythagoras theorem direct. The hypotenuse squared is equal to the sum of the shorter side squared. That is 10 squared. Our hypotenuse is equal to 8 squared plus the shorter side, the other one that we are supposed to calculate, we're just going to write as b squared. 10 squared, that's 100, is equal to 8 squared, 8 times 8, which is 64, plus b squared. So transpose 64 to the other side is going to be 100 minus 64, which is 36, is equal to b squared. So that will be the square root. So b is going to be plus or minus 6, but the answer for side, it is going to be 6. We consider a positive. So as you can see, you're obtaining the same answer, just like what I was saying, if you know your Pythagorean triples, all right? So knowing that here we've got 6 centimeters from this side AB, it means we can calculate our area, because from the bigger triangle, our area is going to be half base times the perpendicular height. Also here, we're going to have half base times perpendicular height for the smaller, because it's a right angle triangle. So for the bigger triangle, this is what you're going to have. That is going to be half of the base. All right, going to consider the base of 6. Sorry for that. So it's going to be half of 6. All right, I need to save. Okay, let me just save, guys. All right. All right, so it's going to be half of from this point to this point, which is a 6. So that's half of 6 times the height. The bigger one up to this point, up to BD. So it's going to be 8 plus 9, which is 17. All right, 8 plus 9, that's 17. Guys, this thing of not using a calculator, it affects your brain. My brain is now damaged. Anyways, let's see. Then we've got the smaller triangle ABC. This one ABC, you're gonna have half base times perpendicular is half of 6 and 8. So it's gonna be half of 6 times 8. So that's it. We've got the area of the bigger triangle and also the area of the smaller triangle. So that'll be what here? Half of 6, that's a 3. Then if you multiply 3 times 17, that'll be 51. All right, that'll be 3 times this 7, which is 21. 3 times 1, which is 3, plus 2, which is 51. Minus, we do the same thing here, half of 6, which is going to be 3. 3 by 8, that would be a 24. All right, so you're going to have 51 minus 24 in this case, which would be something like 27 square centimeters. All right, so that's going to be the area there. That's our area of triangle ACD. All right, we're going to have 27 square centimeters. But the question is, like I said, there are two ways that we could have used. So we are obtaining 27 square centimeters. And the other trick part, they do not even write the units yet. These guys, I don't know what are they taking when they are setting these question papers. Let's just hope they're going to revise. The Department of ZIMSEC, please, we are pleading with you. Can you assist? Can you help us? We need your help. It's actually you in the hands there in power. Actually, we just need our exams to be smooth. You know, let the exams be smooth. Let a child fail because you failed because of your choice, not to say you are limited because of resources, you are limited in terms of answering space. These are the things that we do not want. Anyways, let us consider the second way. The second way could be this way. For those who love to work mathematics, this one is for those who are into mathematics. If you are into mathematics, guys, you're going to consider this. Remember what you did before. this is the triangle that we want to calculate its area, triangle ACD. This is just for a revision sake now, because we considered this. So this is just for a revision sake that we are now doing, or the revision sake that we are just having in this case. All right, sorry for that. I don't know what has happened. So, like I said, this one is now for those who are into mathematics, those ones who want to do calculations. If guys, you understood the first question, don't consider this, please don't. All right, but for those guys, let us talk about this here. Remember the concept that we talked about here on finding cos ACD. Remember what you did here. You used the concept of the acute and obtuse angle concept to find the cosine of ACD, which is this one, ACD. It's impossible for us to have this area because it's a non-right angle triangle. If we were to find our area here, it was supposed to be the area is equal to half AB sine theta, whereby our theta is this angle, which is ACD. So it was supposed to be sine ACD. This was supposed to be your formula, guys. Let's be honest. Guys, let's be honest here. Those guys who are like I was saying, please, if you are into this question, let's be honest, isn't it? That is the condition there. Half AB sine theta, which is half AB theta, which is this one. So what you simply needed there was to find the sine ACD. If you know how to find, if you know how to find cos ACD, then you must also be able to know how to find sine ACD, because next time they are going to ask us to find sine ACD, not cos ACD. So you see, the same way we calculated our cos ACD is the same way that we are going to find our sine ACD. But here we are going to use, remember for cos, I said this one, don't consider this. We are considering this as it is. So you see it's an obtuse angle, but I said in our introduction, the sine of the obtuse angle is the same as the sine of the acute angle. It is only sine which will be positive. So meaning to say our sine of the acute angle, the angle that is inside the shape, this one, this angle inside the shape, this one, is the same as the sine of this angle outside, which is our exterior angle. So remember, the ratio of sine is opposite over hypotenuse from our SOHCAHTOA concept, opposite over hypotenuse. So according to this angle, our opposite is 8, our hypotenuse is 10. Our opposite is 6, so it was gonna be 6 over hypotenuse, which is 10. So this is the sine of theta, which is the sine of the obtuse angle. Let us substitute this. So our area was going to be half of A times B. You multiply A and B, which are the sides that are creating our angle in this case. So that's half of 9 and 10 times sine ACD, of which our sine ACD is the one that we calculated here. Sine ACD, we got 6 over 10 from this. So it was going to be 6 over 10. So that was another way that we could have calculated these areas. You can see it's direct as if you understand this formula, or if you understand the concept of obtuse and acute angle concept. So here let's cancel 10 and 10 cancels. 2 into 2, 1, 2 into 6, that's 3. Then 9 times 3, which was going to be 27 square centimeters. All right, so that could be another way of answering these questions. You can see we are obtaining the same area of 27 square centimeters, just like the one that we obtained in the previous case. All right, question number 14, given the formula, if A is equal to minus 4 and this and that, all right? So it's just a substitution here. 1 over C is equal to the square root of B minus A. So they are asking us to find the value of C. If this is equal to, all right, we are given the values of A and the values of B. So you're just gonna substitute here. So that's 1 over C is equal to the square root of B. Our B is what? 21. So that's 21 minus A. A is a negative, so it's going to be minus for the formula, this one, and the minus for A, all right? our A is carrying a negative, so it will be minus here. So that's it. 1 over C is gonna be, if we add minus and minus, that's a plus, so it will be 21 plus 5, 21 plus 4, which is 25, and the square root of 25 is plus or minus. So it's either you're going to write it as plus or minus, but for substitution, the plus or minus is not important, but you can write this as plus or minus. So the square root of 25, if you take it as a 5, what would be the value of C? This is 1 over C, not C. What about C? So it's now an equation. Cross multiply to find C. 1 times 1, that was going to be a 1 is equal to C times 5, which is 5C. So to find C, divide by 5 here, and you divide by 5 the other side. All right, so let us just save a little bit. I'm just going to save. Sorry for that. So divide by 5 and also by 5. So that will be our C is equal to 1 over 5. So therefore, our C was going to be given as 1 over 5 in this case. You see, guys, being simple, but you can be tricked by being simple there. Make A the subject of the formula. All right, so you're going to have our same formula. 1 over C is equal to this. You see this space is too small. I don't know what they budgeting here. Okay, sorry for that. Okay, it's equal to the square root of B minus A. That will be the square root of B minus A. Remember, I asked you to make A the subject there. So how are you going to make A the subject? The A that we want is under the square root. So there's no way we have to remove the square root. How do you remove the square root? You have to square both sides. So as you square, every time you have to square 1 squared. That's 1 over C squared is equal to, we have removed this square root, so we remain with B minus A. We want to make A the subject, and there we have our A, but it's a negative. So how are we going to make this a positive? Transpose it this side, it becomes a positive. But after transposing to the left-hand side, what am I going to do with 1 minus C squared? I have to transpose it to the other side. So it is going to be B minus 1 over C squared. Guys, A is now the subject. This issue of now combining this, it's up to you. That one is up to you. Already, A is the subject like this. So you're writing it as a single fraction. I don't know whom you want to impress there at the Department of SimSec, but your answer is already done. The moment you now try to write as a fraction, that's where you obtain errors now. You start to make errors there. Solve the following equations. The bracket of 5m minus 3 and the bracket of 2m plus 1 is equal to 0. I said the product of two numbers to be equal to 0. If A and B, they are equal to 0, it simply means one of these must be equal to 0 only when we are talking about equal to 0. So it means this bracket of 5m minus 3 must be equal to 0, or the bracket of 2m plus 1 is equal to 0. This time, SimSec, they tried. This is good. All right, these questions, they're actually nice. All right, transpose minus 3 to the other part, it becomes a positive. So 5m was going to be a positive 3, or 2m is equal to transpose 1 to the other side, it becomes a negative. So to find m here, divide by 5 by 5. So m was going to be 3 over 5, or on this side, transpose, we've transposed, then we divide by 2 by 2. So m was going to be equal to negative half. So these are the two possible values of m. 2 marks for that. All right, solve this equation for any. All right, here it's okay, they just said solve the following equations. All right, okay, that's good. So B, we are given, solve this. So you're going to cross multiply for 2 equations here. I've got 2 fractions, one on the left and the other one on the right. So simply cross multiply. This multiplies here, this multiplies here. So 2 is going to multiply n plus 2, and 3 is going to multiply 3n minus 1. All right, let's expand 2 times n, that's 2n plus 2 times 2, which is 4, 3 times 2, which is 3 times 3, which is 9n, minus 3 times 1, which is 3. Collect our like terms. So the numbers to the one side, so it's going to be 4 plus 3. So that's 4 plus 3 is equal to transpose the letter n there, which is 2n to this side, is going to be a negative. So that's 9n minus 2n. 4 plus 3, that's a 7, is equal to 9 minus 2, that's a 7. So that's 7n there, divided by 7. By 7, this will cancel. So n there was going to be equal to 1, all right? Is it so? Let us just cross-check if n can be equal to 1. Let us just substitute a 1 here. So it's 2 over 3 times 1 minus 1, which is 3 minus 1, which is 2, which is going to. Sorry for that part. I just don't know what happened. But if you prove that back, you're gonna have the same thing. I don't know what's happening with this video. I just hope I'll be able to finish because the way that it is happening here, I don't know. Given the matrix A and the matrix B, find AB in this case. That's the product of A and B. We are given our matrix A, which is 2, 1. That's a 1, and they've got -3, 0 in this case, multiplied to B, which is 2, 5. All right, so if we check the order of the first matrix, it's a 2 by 2. We've got 2 rows and 2 columns in this case. So we are considering a 2 by 2 matrix, which is going to multiply a 2 row by 1 column matrix. So we are considering a 2 by 1 matrix. So as you can see here, multiplication is possible because these two numbers are the same. So multiplication is possible, and our answer is going to be a 2 by 1 matrix. That would be our answer. So applying the concept of row by column concept, we're gonna have 2 times 2 in this case, which is 4, plus 1 times 5, which is a 5. So you're multiplying 2 and 2, get a 4, 1, and a 5, you get a 5. All right. You do the same thing on this part, row by column. Gonna consider this row to the same column. We just have 1 column there. So that's -3 times 2, which is -6, plus 0 times 5, which is a 0 in this case. All right. So if we add 4 plus 5, that's 9. Minus 6 plus 0, that's a -6. So that was going to be our answer. As you can see, it's a 2 by 1 matrix. They've got 2 rows and 1 column in this case. Then the B part, it was to find the inverse of B. 3 marks for that. This question, guys, this question was so nice. So nice. All right. Question number, the B part, we are given the inverse. Remember, to find the inverse of A, we are going to need the determinant of A. All right, so we're going to need 1 over determinant. Then on the matrix part, if it was A, B, C, D, we're going to interchange this. So it would be D and A. Then you multiply B by a negative like that. So that's the formula. So you need the determinant of matrix A first. So the determinant in matrices is the one that I'm indicating with this sign. That's the determinant of A, which is the product of the major diagonal. We've got 2 times 0 there, minus the product of the minor diagonal, which is 1 and -3. So you're going to multiply 1 times -3. That's 2 times 0, which is 0 minus 1 times -3. That's a -3. So you're going to have a plus at the end, minus and minus, that's a plus. So 0 plus 3, that's a 3. So that's the determinant of our matrix A. So in order to have the inverse of A, take note, you're supposed to know these signs, guys, because here you see they're asking in terms of a sign. Sometimes they're not going to write to say the inverse. They will just find A to the power of -1. You're supposed to know. So here they're just writing also for you to say the inverse, but you're supposed to know what the sign represents, okay? So like I said, the inverse of A is going to be 1 over the determinant, which is 1 over 3. So we're going to see that the numbers here in the major diagonal, you're going to interchange them, these two numbers in the major diagonal, 0 and 2. So we are going to have, where there was a 2, we are going to write a 0. So it's going to be 0, 2, like this. And this minor diagonal, we simply multiply by a negative. So that's negative there. That's a C there, -C. So we're just going to multiply these two numbers by a negative. So it's negative times 1, which is -1, negative times -3, which is going to be a +3. So that's -1 and a +3. So you're going to have -1 and a +3 there. That's the inverse. You can multiply with the third inside if you want, but the inverse, just like that, guys, you're fine. All right, question number 17, we are given, that's a vector, given vector OP, which is given as 4, 1, where O is the origin of the origin and Q is the point. In the matrices, we don't talk about the origin. The origin we talk about on a vector. So this is a vector, right? So the first part was to find the modulus. These lines now, you see them on a vector. it represents the modulus. On the matrix, it represents a determinant. These lines that I was indicating here, these two, it's determinant under matrices. Under a vector, the same lines, they represent the magnitude or the modulus of a vector, or the distance or the length of a line. So in this case, the modulus of OP, or the magnitude of OP, is given by the formula x squared plus y squared, whereby we've got the value of x and the value of y on OP. So that is going to be the square root of x here, which is 4 squared, plus y, which is 1 squared. So that's the square root of 4 squared. 4 times 4, that's 16, plus 1 times 1, which is 1. So if we add, we are going to obtain a 17. So that's it. That's why they are saying in said form, meaning to say our answer is going to be under the square root. We can't simplify the square root of 17. Remember, this is paper 1. So you leave it in said form. So that was going to be the square root of 17 units in this case. All right. So that was it. 2 marks for this modulus, all right, which is fine. Let us check the other part on the same question 17. We are given also, we are given Q, all right, QR in this case. Find the coordinates of R, all right. We want to find the coordinates of R in this case. All right, take note, before we are given the point Q. Q is 1, 5, all right. The point Q is 1, 5, remember that. The point Q was given as 1, 5, and we had vector OP, which was given as 4, 1, all right. So in this case, we are being given now to find the coordinates of R. All right, so if we check, you just ask yourself, how did we calculate this vector QR in the first place? To calculate vector QR, we used the formula. QR is going to be OR, which is the last term, minus OQ in this case, which is R minus Q, but we write it as a vector OR minus OQ, whereby OR represents the point R. That's the point R that we just write as a vector. Just like this part, OP, we can write point P as 4, 1. OP represents the column vector for the point P, all right? So that is the condition there. So we've got a vector QR, which is -2, -3. Let us substitute -2, -3 is equal to vector OR. So that's OR minus OQ. OQ is the vector Q, which is the column vector of Q. From the point Q, just write as a column vector. So as you can see, we can find our vector OR. If we transpose this to the other side, it will be a positive. So that's -2, -3 plus 1, 5 in this case is going to give us vector OR. By finding vector OR, we are finding the point R in this case. All right, so vector OR from the origin is going to be -2 plus 1, which is -1. -3 plus 5, that is 5 minus 3, which is 2, all right, if I'm not mistaken there. So this is our vector R in this case, OR, this vector, a column vector from the origin. So it follows that the point R is going to be taken as, all right, this is point R, which is going to be taken as -1, 2. Okay, so that's it. That's our question B, item 1. We're going to have our point R as -1, 2. The coordinates, we need the coordinates, so that's why I write as point xy like that. All right, then from there, they need us to calculate vector PR. So in order for us to find this vector PR, we're going to use OR minus OP, which is from the starting point, which is OP. So we're just going to substitute. Remember, we calculated OR, which is from the point R. We've got our OR here, which is -1, 2. So it's a continuation, minus OP. OP is the point P, just we have, which is this one, OP. We are given OP as 4, 1. So we're just going to substitute 4, 1. So it was just a continuation, this one. All right, so that's 4, 1. Let us subtract -4, -1, -4, that's -5, 2 minus 1, which is a 1. All right, subtract the corresponding terms in this case. So that was vector PR, 1 mark. As you can see, guys, it's just 1 mark there. It was just a matter of your substitution. All right, then on this question number 8, is it question 8 or 18? Oh, it can't be question 8 this time. What was this question? The item 1, it can't be question 8, man. It is, 17, 18. I'm surprised, guys, to say how so. All right, so that's question 18. No, all right, no problem. Let us get our question back. We're given on this question. All right, where's our question here? All right, let's just hope I can be able to see clearly. But what is important here? These are continuous lines. I don't know, but I see like these are continuous lines. I don't know what you see, but that's 1, 2, 3, 4, 5, and so on and so on. These are the x values. Here it's 1, 2, 3, 4, 5, and that's a 6 there. So it's going to be a 6. These are the y values. These are continuous lines, and these are continuous lines. I think so. I'm not sure as it was. It's not clear. But the question there was in the diagram. The unshaded region R is defined by 3 inequalities. Find the 3 inequalities. All right. So let us find our inequalities. In order for you to have the inequalities, you must have the equation first. So let us consider the first equation is this one of this line here. We've got this line, which is the line of y is equal to 1. It passes through 1. In the y-axis, it's a horizontal line passing through y is equal to 1. So this line is of y is equal to 1. So the inequality, as you can see, they're talking about the inequality of the part that is not shaded. This is the region that we are considering R inside. So according to this region, these values here on top, they are greater than 1. These values shaded here, they are less than. Remember, I said when you're given a horizontal line like this, on top it's greater than, below it's less than. So as we are talking about what is on top, so it means our inequality y is going to be greater than 1. That's it. All right. So that is how you consider a line. If you're given a slanted line like this, the top part is the greater part. This part down is your lesser than. All right. If you're given also like, as you can see, it's the same line. So this is the top part according to this line. This is our top part, this one. So it will be greater than here. It will be less than this side. All right. If you're given a line like this will be the greater than side. The part below, the part always down, it's less than. On top, it's always bigger than. That's it. So you just have to find the equation. Then you put your inequality there. So here we're going to find the equation of this line. All right, so if we check this line, it passes through the point here in the x-axis, that's at 5. This line here in the x-axis, it passes at 5. In the y-axis at 6. So you can use y is equal to mx plus c, find the gradient and so forth, all right? Or you can consider whatever way. So using the form of y is equal to mx plus c, it means y is equal to the gradient, which is the change in y over the change in x, all right? So meaning say the change in y, we're gonna go down. Going down here is gonna be -6. The change in y we're going down, so it will be a -6 there. So that's -6, the change in y over the change in x from the 0 up to 5, from 0 here up to this 0.5, that will be positive. We are going to the positive. So our gradient is going to be -5 over 6x. Or you can use the points to find the gradient. This point here, it's 0.6. This point here, where it passes through the x-axis, it's 5.0. You use the points, you find your gradient, still you're going to have the same answer. Then you determine your equation, still you're going to have the same answer that we're going to have here. So plus c, which is the y-intercept, it passes the y-intercept at 6. So that will be our equation. So from this equation, it follows that we said we want to consider this side here. We are talking about this line. So we are considering the side that is not shaded is this side here. And this side, we said the sign there is going to be less than. So we are going to use the less than sign. So our answer was supposed to be y is less than -6 over 5x plus 6 like this. That will be our answer. Right. If you want to write the same answer that you have, you can write it in many ways. All right. Let me just write it on top here. Y is less than -6 over 5x. All right. The other thing here, these lines, guys, they are continuous lines. All right. These lines, they are continuous. They are not broken. So it's going to be less than or equal to, greater than or equal to, less than or equal to. All right. So here we are having y is less than or equal to -5 over 6 plus 6. You can also remove the fraction, multiply by 5, by 5, by 5 this side. So our equation can also be given as 5y. This cancels. we've got -6. We take it to the other side, it becomes a +6, less or equal to 6 times 5, which is 30. So you can have your equation this way, or 6x plus 5y is less than or equal to 30. Guys, you can write in any way that you want, still representing the same thing. All right. So that was supposed to be our inequality. All right. Since it is a continuous line, it's going to be equal to. Okay. We move on to the other line that you're going to consider. This line, it passes through 6 on the y-axis. On the x-axis, it passes through the point 2. So you're going to use the same concept. Find the equation first. Y is equal to mx plus c, where m is the gradient. So the change in y up to 0, from 6 here up to 0, then from 0 up to 2. So it's going to be down, which is a negative. Then from this side to this side, we are going to the positive. So that will be -6 over +2. So -6 over +2 cancels, you get a -3. So y is equal to the gradient, which is mx, that would be -3x plus c. C is the y-intercept, which is at 6. So the same equation, you could have find this equation using the points where this line it passes through 0,6. So that's a point. You write your point 0,6. Then also it passes through this point 2,0. Okay, these points are enough for you to find the equation. You find your gradient, then determine the equation. I think we understand that concept. Then considering, according to this line, the side that is not shaded, according to this line here, is this side on top here. And I said on top, you use a greater than. So the sign here was going to be y is greater than -3x plus 6. Since it is a continuous line, it is going to be greater than or equal to. All right, so that's it. Or you can even have this, you can take the 3 to this side. These numbers are in any way. So these were 3 inequalities, this one, and this one. All right, this was direct. Okay, 3 inequalities, we've got 5 marks for that. Okay, so many say 2 marks, 2 marks. Okay, that was a lot. This was this time our ZIMSEC department, they tried by all means, guys, to push you. Here they tried by all means. All right, another question. The diagram shows a speed time graph of a moving object of a period of 10 seconds. All right, so that's from 0 to 3. That's at constant velocity, which is constant speed. Then from 3 to 7, there's an acceleration. Then from 7 to 10, there is a deceleration that is happening there. All right, so the question is, calculate the acceleration of the object from t is equal to 3 to t is equal to 7. And we noticed that from t is equal to 3 to t is equal to 7, there is an acceleration which is happening. So remember that acceleration is the change in velocity over the change in time. Or you can use points if you want. You can take, just like gradient, you can take points. This is x, which is t, which is 3, and here it's 20. So you can use the point 320, and here it's 7, here it's 30. So it's 7 versus 30, 7 versus 30. You calculate the gradient the same way you calculate your gradient, the change in y, which is going to be acceleration is going to be change in y over the change, just the same way you calculate your gradient. So there you're going to have the change in y, which is y2 minus, so it's going to be like x1, x2, x1, y1 here, x2, y2. So that's 30 minus 20, 30 minus 20 over x2, which is 7 minus 3, which will be here. That's a 10, that's a 4. So divide by 2 here, that's 2, that's 5, which is 2 into 5, that will be 2, remainder 1, comma, that's a 0 there. So it's going to be 2,5 meters per square second. That's our acceleration. Or you can use the proper formula. Acceleration is the change in velocity over the change in time. That's v2 minus v1 over t2 minus t1. So the velocity, it changed from this point to this point. So that means our v2 and v1 are the velocities corresponding. The last point, that's our v2, which is at 30, minus v1, which is at 20, over t2, the time at 2, here is 7, minus the time at 1, which is 3. So as you can see, it's a repetition of what we just had here. 30 minus 20 over 7 minus 3 is just repetition. So you're going to have your answer as 3,5 meters per square second. So that was the acceleration in this case, all right? So 2,5. So the acceleration here was going to be 2,5 meters per square second. That's how we could have calculated our acceleration. All right, that's 1 mark for that. Okay, so that's why you see it's just 1 mark. Anyways, let us check the other part of the question. Then on the other part of the question, we are now given the distance covered by the object at constant speed. All right, we need at constant speed. Distance, remember, is area. So at constant speed, where is the object maintaining the same speed that is along here? That's our constant speed. So we need the area there. Distance is the area. All right, so that's our item B. So our distance is simply equal to the area in this case, whereby you're talking about base side length times width from the area of a rectangle. Is going to be length times width, which is from this point to this point is 20 times from this point to this point it's 3. So 20 times 3, that will be 60. So this is distance, going to be 60 meters. Yes, we are calculating area, but it's distance. So you write it as meters. So the distance here was going to be 60 meters. All right. Then the average speed after 10 seconds. All right. Average speed after 10 seconds. All right. You have to calculate a lot of things. How many marks was that? All right, 3 marks. That's why. All right, that's 3 marks. That's why. All right, because we're going to need a lot of things. In order for you to have the average speed, you must have the area for everything. I mean, the distance for every part. Remember, we calculated the distance here. We got 60 meters. So we are going to calculate for 10 seconds from 0 to 10. We're going to calculate the area for every part, which is the distance. So we are going to calculate also because remember that average velocity is the total distance traveled over the total time taken. That is the speed. So just from the speed concept, distance over time taken. So in order for us to have this, we are supposed to calculate the total distance. We need this one and also need this one. All right, so here we can just consider it as a trapezium. Yes, you can see, guys, we are forming a trapezium. So you're going to consider from 3 to 7, our distance there is going to be of a trapezium. Half sum of parallel sides times the perpendicular height. So that these are the sides which are parallel. So it's going to be half of from this point to this point, that's our 20. So it's going to be 20 plus from this point to this point here, that's 30. So it's half of 20 plus 30 times the height. From 3 up to 7, that's our height. So you subtract 7 minus 3, that is going to be a 4. So you're going to have a 4 here. All right, so you can calculate our distance from this. Half of 4, that is a 2. So here we can add 20 plus 30, which is 50 times 2, which is 100. So you're going to have 100 meters. So meaning to say between 3 and 7 seconds, we have traveled a distance of 100 meters. All right. Then we calculate between 7 and 10 seconds. We're going to have a distance there. And what shape are we having there? That's a triangle in this case, and this is a right angle triangle. So remember that area, we are simply calculating the distance is area. So it's going to be half base times perpendicular height, which is half of the base from this point 7 up to 10. There's a distance of 10 minus 7, which is 3, times the height from this point up to this point. That's our height, which corresponds to 30. So that's 30 there. So you can find half of 30, that's 15. 3 times 5, which is 15, got a 1. 3 here, which is 3 plus 1, which is 4. So that will be 45 meters. So we are going to have 45 meters, okay? So we combine everything. That's our total distance in this case. We're gonna combine each and every part. That's the total distance in this case. We're gonna have the total distance traveled, which is 60 meters plus 100 meters plus 45 meters. All right. So if we add 60 plus 45, that's 105 plus 100, which is 205. Just to hope I'm not mistaken. So that's 205 meters. All right. So the question there was to calculate the average speed of the whole journey, which is the average speed for the 10 seconds. This is for the whole journey. After 10 seconds, we need to say after 10. After 10 here, our average speed, speed, which is taken from the total distance traveled over the total time taken. All right, total distance traveled over total time taken, which is the total distance traveled 205 over the total time taken, which is 10. So if we divide, that was gonna just 1 comma there, which is 20.5 meters per second. Remember, this is speed measured in meters per second. So the average speed is gonna be in meters per second. All right, that's it. It was a nice question. Guys, I haven't seen something like this before. It's like I don't know, but it was a nice question paper. Nice question paper. You just needed to be stable or on answering. You just needed that stable mind. You don't think a lot, just be stable. All right, anyways, let us check the other part. Factorize completely. That was the question 20 here. We are asked you to factorize completely each and every part that we're gonna have. Let's check where are the questions. They're on the next page. So each part we're gonna factorize. Now I can't see here. Is it 18 or 14? I don't know. Is it 18x squared minus 2x? I can't see properly. If it was like this, we're just gonna factor out 2x, and this would be 18 divided by 2, which is 9, x squared, and x, which is x minus 1. Yeah, I can't see properly, guys. Please just forgive me. And also this one, I can't. Is it 4x minus what? 4x squared. Okay, for these questions, guys, just send me. Here we affected a lot. Question 21, also it's affected. Okay, guys, so just send me these questions if you've got clear questions, and so that I'll just work on them. Here it has affected us a lot. All right, so let's see question 22, which is probability. They are saying that Dan is a striker. So there's a person, Dan, who is a striker here for the under 17 boys soccer team at his school. The probability that he scores during the first half of the match is 0.6. All right, this is the first half. So in order to score, it's 0.6 in order for him to score. What about not to score? It's going to be 1 minus 0. Remember, probability always it add up to 1. So you're just going to subtract 1 minus 0.6, which would be 0.4. So here it was going to be a 0.4. All right, let's move on. Then if he scores during the first half, if he scores like this part, the probability of scoring the second, he scores the first one, then he scores the second is going to be 0.8. So if this is 0.8, what about does not score? Remember, probability is equal to 1. So 1 minus 0.8, it's 0.2. So meaning to say not to score is going to be 0.2. All right. Then here they are saying if he does not score, during the first half, all right, we are considering here, if he doesn't score here, then to score for the second one is going to be 0.5. The probability of scoring for the second one is going to be 0.5. What about not scoring? Is going to be 0.5. 1 minus 0.5, which is 0.5. So that is the information that we are given. Probability of each branch. If you add this, you must get 1. If you add this, you must get 1. If you add this, you must get a 1. That is probability of happening and not happening. So the first question was to complete the tree diagram. Already we have completed. All right, so we're just gonna complete this by inserting, all right, 3 marks for that. All right, so we just subtracted this one from 1, this one from 1, this one from 1. That is how we can answer this part. All right, so that was clear. B part, we are now given, use the tree diagram to find the probability that he scores in both halves. Okay, he scores, so he's going to score in both halves. Okay, so we're going to check here. The first half he scored, the second half he has to score. All right, here the first half he scored, the second one he didn't. Here he scores for the second half, but the first one he didn't, so it's not going to work. Here it's not going to work. So in order for him to score in these halves, we're gonna have the first half and the second half. That is the probability for him to score in these two. So our answer was going to be the product of 0.6 and 0.8. All right, so it was just going to be a product of 0.6 and 0.8. So that's 0.6 times 0.8. All right, so if you multiply 6 times 8, that's 42. All right, is that so? 1 omen decimal place, 1, 2 decimal place, 1, 2. So it's going to be 0.42 or 42 over 100. You reduce it. All right, then for him to score only once, all right, only once, it means one is going to score, another one is going to lose. So we are going to work with those ones that we left out in the other place. Which part we left out? We left this one of scoring and not scoring. We left out this outcome, and also does not score, and scores. We are going to take this one, but we are not going to take this one because here it does not score, does not score. They are saying he is supposed to score once. So it's either he's going to score in the first half, then does not score the second half, which is 0.6 and 0.2. So to score in the first half, that would be 0.6, and not to score, it would be 0.2 in this case, plus that is when he scored the first half and the second half does not score, or he cannot score in the first half, but he scores in the second half, meaning to say we're gonna need 0.4 and 0.5. All right, so they're gonna need the product of 0.4 and 0.5. So we need the product here with 0.5. All right, so that was it. We are going to combine the two outcomes. So let's multiply 2 times 6, that's 12. 2 decimal place, 1, 2, so it's gonna be 0.12 plus 5 times 4, which is 20. 2 decimal place is gonna be 0.20. So if we add 2 plus 0 here, that's 2. 1 plus 2, which is 3. So it's gonna be 0.32. Okay, that's it. That's it. 2 marks for that. Number 23, given log 8, evaluate log 0.2. From log 8, how can we find log 0.8? Remember, here we just have to write, if you're given this, we are in base of 10. So in base of 10, it means you're supposed to also know the logarithm of 1 in base of 10, which is 0. The logarithm of 10 in base of 10, which is equal to 1. The logarithm of 100 in base of 10, which is equal to 2. I talked about this. Logarithm of 1000 in base of 10 is equal to the number of zeros is your answer. So 10, it's 1, 100 is 2. On 1, we do not have a 0 here, so it's going to be a 0. So log 0.8 is same as log 8 over 10. So what does it mean? From our logarithms, when we are dividing the numbers, it means we were subtracting the logarithms before. Log of 8 minus the log of 10. And we have the log of 8 here, which is 0.9031 minus the logarithm of 10. And you said the logarithm of 10, you are supposed to know it. You are in base of 10. This one, they expect you to know it by head. So we are subtracting a smaller number from a bigger number. We're going to subtract 1,000. Subtract the bigger number, the smaller number from the bigger number. Then we use what? A negative. So here's going to be 1. That's a 4. And we've got a 9 there. Give a 1 here. That's a 1. 10 minus 4, that's a 6. 1 here, that's a 10. And this will be a 10. 10 minus 1, that's a 9. 1 here, that's a 1. So 10 minus 10, that's a 0, 1 minus 1, that's a 0. So it's going to be a negative on your answer. So the answer is going to be negative 0.0969. Let us just confirm. We are in paper 1, yes, but I'm just going to use calculator to confirm here. 0.9031 minus 1, like this is going to be minus 0, okay, which is fine. So this is what you're going to have. All right, we're just going to use the logarithm of 8 that you're given and the logarithm of 10. Like I said, you're supposed to know that logarithm of 10 by heart. All right, so that was the idea of the question. Then the other part is log 512. All right, how can we obtain 512 from 8? That is the question. How can we obtain 512 from 8? So 512 is 8 to the exponent of 3. That's 8 times 8 times 8. So we can write this because we want to have it in terms of log 8, because that is what we are given. They were given log 8. And once we are given an exponent, remember you drop the exponent to multiply the logarithm. So it's going to be 3 log 8. Now we can, 3 log 8 means 3 times, that's 3 log 8. So it's 3 times the value of log 8 that we are given here. And the value of log 8 is what? We are given that it's 0.9 031, 0.9 031. So you're going to multiply by 3. 3 times 1 here, that will be a 3. 3 times 3, which is 27. We give a 2. 3 times 0 here, that's a 0 plus 2, which is a 2. 3 times 9. 3 times 3, which is a 9. So is that so? 3 times 3, I'm making a mistake here. That's an, now I'm using the exponent here. 3 and 1, that's a 3. 3 and 3, that's a 9. Then 3 and 0 here, that's a 0. 3 and 9, which is a 27. We've got a 2. 3 times 0, that's a 0 plus 2, which is going to be 2. Or main decimal place 1, 2, 3, 4. So it's going to be 2 comma. Okay, let's check. Let's confirm. Let's put our calculator to confirm, because here, guys, 3 times 0.9031 like this. So that's 2.7. Okay, which is fine. Let us move on to the other part, the logarithm of 2 in this case. What was going to be logarithm from log 8? How can you write log 8 in terms of log 2? That is the question. How can we write log 2 in terms of log 8? Guys, are we understanding each other here? Okay. This is different from having something of this nature. I want you to be clear here. It's different from given log 2, and you want to write this log 8 in terms of log 2, where you're going to say log 8 in terms of log 2 is log 2 to the exponent of 3, 2 times which we get 8. But in terms of, we want to write log 2 in terms of log. So log 2 must be taken to log 8, because we are given log 8. We are given 8, not 2. So we are supposed to write this in terms of 8. It means log 8 to the exponent of a third. 8 to the exponent of a third, the cube root of 8 means the cube root of 8, and the cube root of 8 is 2. So in order for you to get 2, you must have the cube root of 8, which is to the exponent of a third, just like what we had here. 8 to the power of 3, it's 512. We never changed the question. The question is still the same, but we just wrote it in terms of 8. It is the same thing. 8 to the power of a third is 2. We did not change the question. We're just writing the same 2, but in terms of 8. So as we saw from the previous case, we have to drop the exponent. So it is going to be a third log of 8. And we have the log of 8 here. The log of 8 is 0, comma. Remember, we are given the logarithm of 8. So it's going to be a third times 0.9031. All right, so that was our question there. So we are supposed to divide 3 into this, that's 0.3 into 9, which is 3. 3 into 0, that's a 0. 3 into 3, that's a 1. 3 into a 0, this one. 3 into a 1, this one is going to be a 0. Remainder, so it's just going to be remainder 1, 1, 1, and so on. Put a 0 there. So 3 into 10 to be a 3, remainder 1, 0, 3, and so on and so on. So this one we can just write as 0.3010. All right, to 4 decimal place, just like these numbers were given to 4 decimal place. So you also write your answer to 4 decimal place. So these are not values which are these values that we are getting here, guys. They are not like an assumption. These are rounded off figures that you obtain if you use your calculator like this. I want you to show, we are calculating log 2 right now. If you use your calculator like this, logarithm of 2, I want you to see the answer. 0.301 and so on and so on. These are the answers approximately that we are getting. Even if you had to check here, the logarithm of 512, we get this answer. So if it was in paper 2, that if it was, we have got calculators, we can even use the calculator to prove our answers. This is 2,7, the same answers that we get here. So this is not like we are just, with these values, we're just taken from nowhere. They give you values. They just think if this value out of their heads, they just, okay, let me write log 2 is equal to 5. There's no magic like that. These are values that are exact values. So if you calculate, you obtain exactly what your calculator was supposed to give you, but as a rounded figure. All right, question number 24, evaluate the following as a, number 24, you're given this type of a question. Guys, what type of a question paper is this? This was supposed to be number 1. All right, anyways, they were asked to subtract, I don't know, is it a subtraction or it's a plus, but I think it's a subtraction there. So let us have our LCM of 4 and 7, which is 28. So 28 divided by 4, that is 7. Then the 7 multiplies the numerator minus 28 divided by 7, which is 4. It multiplies the numerator on top. So that's it, 7 times 3, which is 21, minus 4 times 2, which is 8. Everything over 28. So we are going to subtract 21 minus 8, which is 13. All right, so that's 13 over 28. 2 marks for that. All right, let us just confirm, because we might say it's easy, while at least we are writing the wrong thing here. So let's just confirm. This is 3 over 4 minus 2 over, is it 2 or 3? 2 over 7. All right, so that's 3 over 4 like this, minus 2 over 7. That will be 13 over 28. Okay, this is fine. We are in the right direction. All right, so that's it. Number 24. Why are they asking this question on number 24? Where is the question on transformation? There's no transformation here. All right, 2 1/4 divide by 3. All right, is it a divide or is it a plus? But that's a divide, and that's a divide. 2 1/4 like this, divide by 3. All right, so just convert this to improper. 4 times 2, which is 8 plus 1, that's 9 over 4. Divided to 3. 3 is same as 3 over 1. So remember that if you are dividing, you introduce multiplication. The moment you introduce multiplication, you invert the second fraction. So it's going to be 1 over 3. And here we can reduce the numerator and the denominator. 3 into 3, that's 1. 3 into 9, that is 3. 3 times 1, the numerator and the numerator, they multiply each other. So it's going to be 3 over 4 times 1, which is a 4. So that was going to be 3 over 4. Express 0,135 as a common fraction in its simplest form. Are they real about this? As a single fraction, 0,135, how many decimal place? 1, 2, 3. So it's going to be 135 over 1,003 zeros, all right? So you can reduce by the smaller number until you get the answer, guys. Now, let us just use our calculators, guys. But you're going to reduce this, and 135, let us just see what we're supposed to have. 135 over 1,000. You were going to get 27 over 200. All right, so this was going to give you 27 over 200. All right, but you're not supposed to use a calculator. You're supposed to reduce. You can try by 25 until you get the answer at the end. You can try by 5 until you get that answer. All right, guys, are we done? Huh? Which question number is this one? Are we done? Like, for real, are we done? 24. Zimsek, 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 Zimsek. What are we trying to do? We're done. Okay. Oh, I'm surprised. Guys, I'm surprised. This question paper, they're asking the question number 1 on last question. All right, anyways, that was our question, guys. Let us share our videos to our friends and colleagues. Don't forget to have or to communicate with us so that we can be able to play around our questions. 864-864-4043. All right, let's be in contact for any corrections. Maybe there's any mistake that we made. Do not hesitate. There are people who do not know how to correct. If there's a mistake, there are ways of talking about a mistake. Not just guys. It's not this maths is not something that we started now. Like I'm learning mathematics. No, I'm not learning mathematics. I know what I'm doing. So It can be just an error. Maybe I'm rushing, I'm under pressure, this and that. I'm not doing this. I'm not like helping you guys only. I'm also helping the guys for engineering. There's a lot. So corrections, they're there, but let's know how to say it if there's a correction. Anyways, guys, let there be light in whatever that we are doing. Let's continue to share the light to our friends and colleagues. The light must definitely shine in whatever that we are doing, expecting for the best to come in whatever that we do. For those who have written now you are going to be thinking of, okay, what am I going to do from now? That is the question. What am I going to do? Am I going to focus on doing my A level? Am I going to focus on engineering, whatever that you want to do in the future? This sets you up to know where you are right now. If you want to upgrade your mark, this is the right time to start upgrading your mark. Do not relax for the results to come. After writing an exam, you feel it, you know it, that this exam, I have made it. It's something that you feel, not to say that you try to scare people when the results are out. Say, I'm even surprised what happened. There's nothing like that. There's no surprise when it comes to the result. You know what you wrote. Fair enough, we've got a revision. Now you know clearly what you wrote. So for those who want to do their rewrite, start now. For those who are seeing that, okay, this is enough, I can proceed with these marks, start now again to revise for whatever that you want to do. Is it A level? By now, you must be knowing the topics in A level. Which one is the simplest one? Targeting, seeing. Is it engineering? What are the subjects? What are the courses there in engineering? Don't wait for the time of interviews. That's when you just say, any course, I'm going to take it. It's not good. Prepare yourselves now. This is the right time to prepare. Anyways, guys, we shall talk about this. I just hope I'm gonna have a nice video that I just talk about the career guidance, guidance in terms of what we're gonna do in the future from what we have done now. Because some of us, we are limited to what people say. Some of us, we are limited to what other people are doing. Do you. What you feel is, this is me. I feel like in this thing I can excel. Not to say others are into this. Okay, just because of our economy, this and that, sometimes we end up running into what others are doing. But the right thing, follow your heart and in whatever that you do. Like I said, I shall just talk about another video about this issue of career guidance, what I'm going to do in terms of the course, in terms of going to A level, so that you do the varsity level and so on. We shall just find time for that. But for now, that's it, guys. Till we meet again.